at Kankavati river section, Miocene river section, downstream of what classical Miani Kankavati section is. We are still in the upper Miocene, and what we see here is a very argillaceous limestone with lot of clay content, and there is a variation from shale where here you have a very more than 6 feet shale clay unit, followed by a small interval of limestone which has an omission surface on the top. Probably there are some borings here, and then you have again a shale unit which has lot of limestone burrows into it. On the top of it you are having around 6 feet of thick limestone which is thoroughly bioturbated. Now this kind of units, they give a very unique reservoir properties, whereby this limestones, you have primary porosity preserved in the fossils. But since this is a Miocene, we know from the Kachchh limestones of Miocene and the thin section produced from there, the primary porosity is completely choked up with the segregation or the this one of calcite. Then but there are secondary porosity developed in as a form of vuggy porosity. This burrows, they also give very good porosity and permeable path. These are the burrows you can see here. Most of these burrows are horizontal in nature, and therefore they give lot of horizontal permeability.
65 million years.
Yeah, this is around 40 million.
See, again we are here at around 40 million years old. We are touching a rock which is 40 million years old. You can visualize that we are touching a layer of Miocene of equivalent to L3 reservoir, from where our Bombay High is producing. Imagine that this is a shale layer and then this is a limestone layer. When we are drilling a vertical well and we are bypassing all these layers, and then we are producing from a vertical well. In Bombay High, we have not drilled, in L3 reservoir, we have not drilled horizontal well for around 25 years. The first well which we have drilled in N16H in 97, it has given us a very good quantity of oil. We can explain this with the help of these burrows. These are the horizontal burrows. When we have drilled a horizontal well and our well trajectory was synchronized with these type of burrows, it has given a huge amount of oil. When the vertical wells were giving around 500 or 800 barrels of oil, these type of wells have given 6,000 barrels of oil per day. So where we have to look for these type of burrows, these burrows are providing a porosity and permeability which can help in fluid flow through porous media, and we are giving a very good productivity, and our PI is very high from these type of wells.
Okay. Now, whenever we study the carbonate reservoir, one thing is very unique in carbonate reservoir. For kilometers and kilometers, the carbonate thickness can remain same. But on other hand, the carbonate reservoir shows drastic variation in petrophysical properties. For here we are hardly few meters, hardly 1 meter away from the earlier section, and what we see here is again the same sequence, but here the content of fossil has increased. Now this fossil give primary porosity. See, you have oysters, pectins, astropectins, and lot of fun. And then you see here in the lower section, these are burrows. But you have seen the other part has been eroded, giving that is, this is an initiation of the vuggy porosity. You can see all cavernous structure present here. Yeah, you can see it is a huge cavernous thing. On the top, if you just look on the above, you have so many burrows, and the remaining matrix is dissolved, giving a kind of preferential vuggy porosity. Sir,
if we see this, compare this with the Neelam field part. In Neelam we are telling that we have a monotonous limestone in B zone. However, when we are going from north to south in Neelam field, the Neelam 10 and 11 platforms, we are not able to produce. Why? Because that is a wuggy, and this is type of wugs and caverns which are giving us difficulty in drilling the wells. When we are drilling a wells, we are facing the difficulty. Even trajectory of the well cannot be controlled, or when we are perforating either at GOC or OWC, always we are getting gas. So this is a basic reason. Imagine the caverns and works which are here. Similar type of cavern and works are there in the northern part of Neelam, which is not present in the Neelam central and below part. Neelam central and below part has already given 30% porosity, 30% of the oil, but the top portion Neelam, that is the northern portion of the Neelam, has given only 7 to 8%. So this is the reason that we are not able to characterize the reservoir of Neelam 10 and 11 area, because they are of this type. See the type of caverns, and where we can put our hand inside these caverns, and we have big caverns and wuggy porosity. This porosity is difficult to model in a reservoir, and that's why the prediction, even in the prediction, we are facing the problem. If we are doing the reservoir characterization of these type of wuggy porosity and the caverns, then only we can formulate a exploitation strategy for the Neelam 10 and 11 part, and we can produce huge amount of oil.